In the previous movie, I showed you a way to draw a graph that visualizes the way probability is combined to perform Bayesian analysis. In this movie, I will show you how to create a classification matrix, which will take us one step closer to implementing this analysis in Excel. So let's review what we know about our base rates and our accuracy. First, we know that the base rate of green cabs is 85%. That means that 15% of the cabs will be blue. Also, we know that witnesses are accurate as for color identification 80% of the time. And again, the cab can be green or blue. Also, the witness can be accurate or not. And those are the factors that we will use to create a 2x2 probability or classification matrix so we know the probability of arriving at each combination. So let's take a look at a classification matrix. Here's the data again. I won't repeat it, but here is what the matrix looks like. And it is the compound probability of reaching each of these four states. So a green cab will be reported as green 68% of the time. And that's the multiple of 0.85 times 0.8. In a similar way, if a cab is blue, it will be reported as blue 12% of the time, or 0.12. Adding those two values reflects the amount of time that the witness will be correct, 80% of the time. And you can see that the other two cells have the values 0.17 and 0.03. Those add to 0.2, and those are the incorrect guesses. Now, let's take a look at the probabilities of each of these scenarios from the standpoint of witness accuracy. Here again is the classification matrix, and let's do the calculation that we did for reporting a cab as blue and finding the probability it's actually blue for each of the four scenarios. So we have the probability of a cab being blue and reported as blue as 41%. That's the calculation I described earlier. On the other hand, the witness will identify a blue cab as green. That's the second item, 59% of the time. And you can see that 41% and 59 add up to 100%. So if the cab's blue, that's the percent of the time that the witness will be correct. Then at the bottom, we have these same scenarios, but we're assuming the cab is green. So if the cab is green and the witness reports it as green, that will happen 96% of the time. On the other hand, the witness will identify a green cab as blue only 4% of the time. And what makes these calculations so different is the base rate. Only 15% of cabs are blue, and that makes the impact of the probability of an improper identification that much greater.